Today we're going to be talking about the basics of recording terminology, and while we're using the Apollo Solo to show how these terms translate to the hardware, it does apply to many different interfaces, many different pieces of hardware across everything that you'll find in a studio. Now, if you're new to recording in general and you want to get production ready sounds with a click of a button, check out my Console Classic Sessions pack. It's specifically for the UAD platform. And with that, you'll find acoustic presets, vocal presets for female artists, for male artists, bass presets, electric guitar presets, everything that you'll need to get your creative juices flowing and make some good sounds. Not only are these good for tracking, but they're also really good for learning as well. So if you're not familiar with some of the basic techniques with the hardware that the software emulates, the Console Classics is a great way to check that out and learn from a pro. And one more thing, please like and subscribe and leave a comment below if there's anything I missed by the end of this video. I'd be happy to go over it with you in a comment, or maybe even make a video on it if it is a big enough topic. So please leave a comment. Now that that's out of the way, let's jump into the first term. All right, so the first term can be found on your Apollo Solo. It's the input button. Now, to go over what an input is, inputs refer to the source of the audio. In a DAW, this usually corresponds to a number relating to the number of inputs on your device. On your device, an input would usually refer to either a high Z jack, a line level jack, or a microphone jack. Now, a high Z jack would be used mainly with electric guitars or bass, so you can plug directly in. Line level is gonna be for external hardware, like something like the Warm Audio bus comp. So if you had one of those, you'd take the output of that, plug it into the input at the line level, and then you're gonna get a good signal there. Next, we have high pass filter. A high pass filter is an electronic filter that passes a signal with a frequency higher than a selected point and reduces the frequencies lower than that point. The amount of reduction or attenuation on that low pass depends on the design of whatever filter that it might be. So something like a Neve might have something different than, say, an SSL low pass filter. High pass filters are also commonly found on equalizers, and they're a great way to reduce unwanted noise when you're tracking. Next, we have 48 volts phantom power. This is found across pretty much every interface or every mic pre. Phantom power is DC electric current sent down your microphone line to power microphones like condenser microphones. So just remember, if you have a condenser mic and you're not getting a signal, always double check to see if that 48 volts is enabled. Moving on, we have pad, and a pad stands for passive attenuation device. The way a pad works is that it simply reduces signal levels before the active amplification process on your preamp. And the reason that you'd use this is to avoid overloading on the signal. So if you have a singer that's really loud, he's like right on the mic, that's a great way to make sure that the microphone capsule doesn't distort and send a distorted signal into your preamp to amplify. Right after that, we have a little circle with a line through it, and that stands for the polarity switch. Now, in multi-miking setups, you're always going to want to check for phase issues. And what phase is basically as a sound wave moves through the air and hits microphones at different time frames, even if they're just off by a little bit, that difference impacts the sound going into your DAW. Now, when you press the polarity switch button, you're inverting the polarity, or you're inverting the signal of waveform that's coming into your device. Now, this is a very complicated topic in and of itself, but if you're ever in a multi-mic situation, you're always gonna wanna A/B this button. You're always gonna wanna press it and engage it and disengage it as you're testing your sounds out, and simply ask yourself, when I press it on, does it sound better? Or if I disengage it, does it sound better? And then go with that. Some characteristics to keep in mind if your sound is out of phase. Typically, it seems like the low end or like the bass frequencies just completely disappear. Other times you can hear like a weird resonance where it kind of sounds like this. You'll hear weird sounds there. So always be checking for that. Next, you'll find a button that says link. And this is common again on numerous different interfaces, but a stereo link, all that's doing is where it's taking, channels 1 and 2, which would be mono signals, and I'll get into that in a minute. But you're taking a mono signal and one's panned hard left, one's panned hard right. So if you had if you could imagine like a microphone in front of me here pointed at me and a microphone here pointed at me, you pan those hard left and right, and now it's acting like your ears here, you know, theoretically. For the purposes of this example, your ears hear in stereo, right? They actually hear, you know, 360 degrees, but for the purposes of this example, you could hear a guitar on the left, a guitar on the right, that would be stereo. And pressing that button just links it into your DAW. So if you're tracking a piano and you want that piano to be one waveform, you'd put the stereo link on, and then in your DAW it would be one wave file rather than two individual tracks that you'd have to manually pan left and right. That's the difference. Now, specific to Apollo Solos, you'll see this preamp button. What is a preamp? Put it simply, a preamp is what's going to amplify your signal going into your DAW. On the Solo, you'll also find a button that says monitor. This is really just referring to your studio monitors or your headphones, right? And then it gives you the choice to change the volume for either or. Another common term that you'll find on the Apollo Solo, on the back of it, you'll see that it says output. This just refers to the routing where the signal is being sent out. Again, you'll see an output for headphones, you'll see an output for your left and right monitors, and that's just telling you where the signal's going. Latency is the amount of delay between what's going into your computer and back out from your computer. Now, this is why I love to use Apollo interfaces, because Apollo interfaces virtually eliminates latency altogether, because while it's sending the signal into your computer, it's also simultaneously sending it directly out of the device and processing on the device as well. So these things are super nifty, and that's why everybody loves them. Another common term that you'll see all the time is clipping, or sometimes it's referred to as peaking. This is just when the signal gets really loud and is clipped off at 0 dB. Another way to think of it is distortion. Another term that you'll come across all the time on internet forums or in a studio environment is headroom. One way to think about headroom is the amount of volume that a channel or a device can take before it starts distorting. The louder a sound is, the less headroom that it has. For example, if a sound is peaking at -5 dB, then it only has 5 decibels of headroom. If it's peaking at -1 dB, it only has 1 decibel of headroom. Now we're on to another one called mono. Another term that you'll hear, and I've kind of hit on it a little bit, is a mono signal versus a stereo signal. A mono signal just means that it's one channel of one signal, and that signal can be panned left or right. By contrast, stereo signal is going to be two signals left and right. So you're going to see one signal all the way to the one side, one signal all the way to the right side, and together those signals make a stereo image, giving the illusion of depth and 3 dimensions and horizontal width. The next term, auxiliary track. An auxiliary track is a track that has no audio on it, but you send audio to it to be processed. For example, like you'd send a vocal track to an aux track to have delay on it. Now you can find aux tracks in UAD console, and you can also build aux tracks in pretty much every DAW. Another type of aux track is known as a bus. The difference between a bus and an auxiliary track is that with a bus, you're sending many tracks to that to be processed. For example, if you have a whole bunch of drums, you'll usually send all the drum tracks to one auxiliary track or bus track to be processed, and now you can just move them, you can move them all together in unison as a group via one fader known as a bus. Something really cool about buses, check out Michael Brower and his ABCD mixing technique. It's an awesome technique. I learned a ton by understanding that. Not endorsed to say this at all, but you can find all his stuff at Mix with the Masters. They put out amazing content. It's absolutely worth a subscription. Next, send. Send is a routing function that you'll find in your DAW or in UAD console or on a real analog console, where you're taking a signal and sending it to, say, like an aux track or a bus. And the key here is that you're sending it without affecting the original sound. Next, we have meter. What's a meter? A meter is a piece of software or a piece of hardware that's used to measure the amplitude or volume of whatever signal is being passed through it. You can see meters, and there's different types of meters. I won't get into all of the different meters. but pretty much every channel strip will have some sort of a meter to see where your volume is and where you're either going to be clipping. Two quick functions you'll hear all the time is mute and solo. There's a little bit of a nuanced difference there, but mute is pretty straightforward. You've seen that on pretty much any device with audio, phones, remote controllers for TVs, right? And it does exactly the same thing. It turns off the sound, mutes it. Alternatively, solo is kind of the inverse of that. It mutes everything but the track that you're selecting. So if you have a track with 100 tracks on it and you just want to listen to one of those, you would solo that track. Let's talk about reverb. What is reverb? Reverb is the sound that a room produces after the sound is done. You can probably hear some reverb in this room right now. I live in a concrete box and it's very reverberant. Now say you have a very dry signal, you can digitally reproduce reverb with some sort of a plugin, like UAD's Capital Chambers is fantastic. The Lexicon 224 is a famous digital reverb and it sounds awesome. If I had to have one reverb, I'd probably pick the Lexicon 224. Next we have delay. Delay is a processor that copies sound and repeats the sound over and over and over, fading slowly out to create an effect. This is commonly used on like vocals and electric guitars. Sometimes you'll hear it on piano, it sounds really cool. You'll also hear it on drums sometimes as well, and it sounds really cool. Like on some Lenny Kravitz songs, check that stuff out, it's awesome. All right, this one has got a lot to unpack. I'm not gonna cover all of it, but if you're planning on doing any sort of engineering long-term, if you're just getting into this and this is your latest hobby, you gotta understand compression and you gotta learn how to use compression. The art of compression is reducing the output volume via the amount of input volume. In other words, when a sound gets louder than a certain level, the compressor is gonna be there to attenuate that sound back down. So you could think of that like a guy riding a fader, right? It's kind of similar to that. And overall, the effect of a compressor controls the dynamics so that loudest parts are closer to the quietest parts, and overall you're getting a more consistent sound. Now in that explanation, I explained this next one, dynamic range. What is dynamic range? Dynamic range is the loud points and soft points over time. The higher the dynamic range, the more difference there is between the loudest and the softest part of your track. So an example would be classical music that has a lot of dynamic range. There's really, really quiet parts and then there's really loud parts. And then a great example of no dynamic range is like some Nickelback music. Now I love me some Nickelback, I think they're fantastic, but they have no dynamic range. And then also like Oasis, I think their engineer coined the term brick wall limiting. I don't know, my brother always told me that. Anyway, what is a decibel? A decibel is the main unit of measurement of volume. A dB is also relative, and there's many different ways to measure volume, so I'm not gonna really go into that. Again, that's probably another topic. And you can find a ton of resources on this, but if you'd like me to make a video on it, I will, just let me know. Next we have bit depth. Now, the difference between bit depth and sample rate, they're really closely tied together and they're very important to understand. Think of bit depth as the resolution. So if you were to look into cameras at all, right, you've got an 8 megapixel camera versus a 24 megapixel camera. The resolution of a 24 megapixel camera is fantastic, really clear, and it gives you a great image of whatever you're capturing. Whereas an 8 megapixel, it's not gonna be as detailed. So it's the same with audio. So again, bit depth refers to the resolution of the audio, so you're gonna get a more accurate representation of whatever you're recording with respect to the dynamic range of whatever you're capturing. Which leads me to the final one that I can think of for the night, which is sample rate. Sample rate, and this is, again, it's like an inverse relationship to bit depth. They work hand in hand. But sample rate refers to the number of snapshots per second of the audio waveform. So if you were to take like a piece of paper and cut it into samples of that sheet of paper and then throw them together, that would be your sample rate. So a common sample rate in audio is 44.1 K. In UAD console, it's at the very bottom. And in most DAWs, you can find it in your settings. Now, really high-end pros, they love to work in 192 at 192K, right? So the sample rate's really, really high. And again, I could probably talk for quite a while on this topic as well as it relates to sound quality. But again, I encourage you kind of jump outside of the channel, maybe do some more research on it. Or if you'd like me to talk on it, just let me know in the comments. I'd be happy to talk about it, but it is a very extensive topic. Just know that the industry standard these days seems to be 96K, but it is very common to be at 44.1, and certainly no issues there. It sounds great. It's been the standard for quite a while, and even at 96K or 192K, as you bounce down and dither down, most of the time when you export, it's gonna go to 44.1 anyway. Make your own judgments on that. So thank you so much for watching, guys. Again, please like and subscribe and leave a comment below if there was anything that I missed that you're still not totally sure on. There was a lot of topics that we covered really quickly. We didn't go into too much depth, but if there was one that you'd like me to cover more in depth, just let me know in the comments. I'd be happy to make a video on it detailing more. For more on UAD console, check out the deep dive video that I made. It should be right here. Thanks for watching, and until next time, cheers.